Hi, my name is William Lewin, and this is my video on sine graphs, or here, function of x equals sine x. So what are the points in a sine graph? Well, we're actually going to be using the unit circle to find these points. There are five basic building block points, I guess you could call them, that we're going to need when we plot sine graphs. Now x is going to equal theta in radians, and y is going to equal sine of theta. Now we know that sine correlates to the y values in each coordinate here on the unit circle, so we're only going to be using the y values here. So let's say x equals theta and theta equals 0, which is right here. Sine of 0 would equal to 0. If x equals pi over 2, then sine of pi over 2 would equal 1 right here. If x equals pi, then sine of pi would equal 0 again, just like right here. And then it goes on for the last 2 points. 3 pi over 2, sine of 3 pi over 2 is equal to negative 1. Sine of 2 pi is equal to 0 again, because it just circles back. And this is what it's going to look like when it's all graphed out. We have 0, 0 here, pi 2, 1, pi and 0, 3 pi over 2 and negative 1, and 2 pi and 0. It's going to start from the origin, it's going to curve up and then down and then end back here. And it's going to repeat this process, but I don't show this here. We'll talk more about that later. And I just put the unit circle here to line up the 1 and negative 1 in the origin, so it's a better visualization. Now we're going to be moving on to an example problem, because we've learned what the graph looks like and how to graph it. But before all that, we need to use the formula to find all the graphing points and plot our points and know what it's going to look like. The formula is going to be f of x equals a sine of b x minus c plus d. Now a is going to refer to the amplitude, which is the height of the line from the midline to the peak or lowest point. It's going to correlate with our range as well, but we'll talk more about that later. Um, this is going to change the y value, and it's multiplying, so it's going to be y times a when we graph out our things. B changes the x value, the period, which we'll talk about later as well. The period is the length of a complete cycle. I'll explain more what that is. And I'll show you too later. C is the horizontal phase shift, x plus c, and d is the vertical phase shift, y plus d. The domain is all real numbers, and the ranges of the parent function is negative 1, 1. The range is going to change depending on the graph. Now let's do our example problem. Graph y equals 2 sine of 1 half x plus 2. So this is where our parent functions were. 0, pi over 2, 0, 1, pi, 0, 3 pi over 2, negative 1, 2 pi, and 0. And we're going to be using these numbers here to make transformations. We're going to start with A. We know A is the amplitude, and the amplitude is the height, and we know height correlates with the y value. And since there's no sign here, we know it's multiplying. So we multiply each y value with 2 here, as you can see. We're going to skip b for now. We're going to go to plus 2. Plus 2 is also d. And we know d relates to the vertical phase shift, and it's adding. So we're going to add 2 to each y value here. Now, as for b, 1 half. It's not as simple as simply multiplying each x value by 1 half. It's a little backwards. Now, the period changes the x value. You'll see what I mean about later, but the period formula is 2 pi over b. And in the parent function, b would equal 1. So the parent function's period is 2 pi. That's the base. That's the basis, 2 pi. Now, since 1 half is b, we're going to put 2 pi over 1 half. And we're going to multiply it by 2 to get rid of the 1 half. So 1 half times 2 equals 1, but then we have to multiply the top as well. And 2 pi times 2 equals 4 pi. Now we have 4 pi over 1, which equals to 4 pi. Now, how can we use this to get a number to move with our x? Well, we know the base is 2 pi, and we're making a transformation to the base. And from 2 pi to 4 pi, that's a multiplication of 2. And knowing that, we can use that value, multiplying by 2, to apply to the x value. That's how our b works out. So in reality, You can look at it backwards. This 1/2 is actually multiplying 2 with the x. Conversely, if this was 2, if b equaled 2, for example, then we would actually be halving all the x values instead of multiplying by 2. That's how it works. That's a simple way to know it, but this is the explanation of why it is the way it is. It's the period, it's all the period. So knowing that now, we're going to multiply each of our x values by 2. And this is what we end up with. 0, 2, pi 4, 2 pi 2, 3 pi 0, excuse me, and 4 pi 2. And this is what our graph is going to look like. It's the green graph here. The blue graph is the parent function, y equals sine x. You can see how much transformation there is. It's a lot different. It's a lot larger too. Now we're going to be breaking down everything. So we talk about the midline. The midline is, if you notice, it's the same number as the horizontal phase shift. Sorry, the vertical phase shift. That's because normally our midline would be 0. So whatever number d is, that's also what the midline is going to be. And you can tell it's the midline because of the amplitude. If you put a dot right here, if you put a dot at the midline and at 4 right here, the peak, you will get 2. That's the amplitude. Similarly, if you go to the midline right here and put a dot right here, the amplitude is also 2. So that's how you would find the midline, the distance between, you know, or if you wanted to find the midline, you could just start from the highest point here and go to the lowest point and divide it by 2. And that's where you find the midline. 4, start from here, 1, 2, 3, 4, and divided by 2, you get 2. That's the midline. That's how you find the midline. Now, the period, you can see it's 4 pi because you just count 1 pi, 2 pi, 3 pi, 4 pi. That's the period. The period is the distance between a complete cycle. And what's a complete cycle? It's when you have all the 5 coordinates that you placed down. They make a complete curve. You can see it makes a complete curve here. Or it'd be easier if you start right here, and that will be a complete curve right here. Just this way. That could also be a period. Start from 0 here to 4 pi, that's one period. That's a full cycle. And yeah, that's basically everything there is to a to a sine graph. The range for this graph, the green graph, would be 0 and 4 because the range changes depending on the graph. It's the lowest to highest point. As the blue one, parent function, would be -1 to 1. And yeah, you could apply the midline up to period. It would also apply to this graph because it's just transformations. That's really it. And yeah, that is my video. Thank you.